And welcome back to our course in trigonometry. We have a couple of more preliminaries to get through before we actually get to the trig functions. So far we have discussed the Pythagorean Theorem. Remember, that relates the side lengths of a right triangle. If you know any two side lengths, you can use the Pythagorean Theorem to figure out the third side length. And we also discussed two special cases of right triangles, the 45-45-90 triangle and the 30-60-90 triangle. And in those situations, in those special cases, if we know any one of the three side lengths, then we can get the two other side lengths without really doing much work. Okay, so a couple of more preliminaries here. In this video we are going to discuss distance in the xy plane and applications of the Pythagorean Theorem. Okay, so let's start out with a quick little example here. So I'm going to give you 2 points in the xy plane. I'm going to give you an x coordinate and a y coordinate for each. And these can basically be anything. Let's do -2, 3, and 7, I don't know, 9. Okay, -2, 3, and 7, 9. Now, I'm sure you remember this from your algebra class, but sort of our starting point here in the xy plane is there, the origin, right? My x-axis is horizontal, my y-axis is vertical. That point has coordinates 0, 0. Okay, so -2, 3 means I go 2 units to the left and 3 units up. So -2, 3 would put me somewhere right about there. And then 7, 9. Starting from the origin, I would count off 7 there and then go up 9. So 7, 9 would put me right about there. Okay, so I got those 2 points. Now I want to find the distance between those 2 points. In other words, I want to find this length right here. Now, if I was walking straight along the grid, then finding length there is easy. So in other words, if I went from this point to, let's say, this point, 3, 0, I haven't gone any vertical distance. Well, that's length 3. You walked right along the grid there. But this is slanted. So what we're going to do is we are going to bring in a little supplementary triangle. Okay, we're going to make a little right triangle here. Okay, now this vertical distance right here, we can tell that's 6. This point has a height of 3 above the x-axis, and this has a height of 9. So we've gone from a height of 3 to a height of 9, so we got 6. Okay, we're getting that from the difference between the two y coordinates. Okay, we're going to apply similar reasoning to find that length. That'll be the difference between the two x coordinates. Okay, this has an x coordinate of -2, this has an x coordinate of 7, so if I start at -2 and I go all the way to 7, well, that's going to be a distance of 2, 7 more, so that's a distance of 9. Okay, the difference between the x coordinates, 7 minus -2, remember, of course, when you subtract a negative, that's equivalent to adding. 7 minus -2 is 9. Okay, so that's the difference between the x's. And I want to find that length. So quick application of the Pythagorean Theorem. 6 squared plus 9 squared equals d squared. If that equation is true, then 6 squared is 36, 9 squared is 81. 81 plus 36 is 117. So d squared equals 117. square root of 117. Okay, now we have talked about simplifying our square roots. Now 117, I am pretty sure that's divisible by 9, and I think that's the biggest perfect square that goes into 117. Let me think on that just a sec. So 9 times what? Okay, so we're doing 9 into 117. So go into 11 one time, you'd have 27. So 9 times 17. No. That's not right. 9 times 13. Okay. Whew. Okay, so 9 times 13 is 117. And of course, the square root of 9, that's something we know. The square root of 9 is 3. Okay, so the distance between these 2 points is 3 radical 13. Okay, so the distance formula that you remember from high school algebra, that's an application of the Pythagorean Theorem that we discussed in this course. Let's do another example of finding distances between 2 points. Okay, so find the distance from 5, 12 to the origin. Okay, so once again, we'll make ourselves a little sketch here. 5, 12, somewhere about there. I would go 5 units to the right and 12 units up, starting at the origin. Okay, and of course we know the origin right here has coordinate 0, 0. So we want to find this length. Well, we do the same trick. We will make ourselves a little supplementary right triangle. Now, this length, well, that's 5 units. This length, that's 12 units. So the distance that we're interested in finding, d, fits into this equation. 5 squared plus 12 squared equals d squared. 12 squared, 144. 5 squared, 25. 144 plus 25 is 169. Now it happens that that's a perfect square. 13 squared is 169, so this is a special case where that actually worked out to be a whole number. Most of the time we have to apply the Pythagorean theorem. It's not going to be a whole number. And as you have probably seen in the last couple of videos, in fact, in all the videos we've worked on so far in our course in trigonometry, we have dealt with square roots. So you're going to need to get comfortable with just leaving a square root as it is if it can't be simplified. That last one we just worked on, 3 radical 13. There's no good way to simplify radical 13, and having it written as 3 radical 13 is actually more useful than the decimal expansion that a calculator would give you. Okay, so just get comfortable leaving the square roots after you've simplified them. But in this case, it simplifies nicely. It just simplifies to 13. Okay, so if you're talking about the distance from a point to the origin, then it's actually a little bit easier. You're just using the x and y coordinates by themselves. You don't have to do that intermediate step. Okay. And I also wanted to do another application of the Pythagorean theorem. Okay, so in this example, let's do this one here. A softball diamond is a square with side length 60 feet. Okay, so we got a square of side length 60 feet. Okay, find the distance from first to third. Alright, so let me make a little sketch here of our baseball, or softball rather, diamond. Okay, so that's first base, second base, that's third base, there's home plate down there. Okay, so the side is 60 feet. Now, I'm just going to clarify a little bit here. When we say find the distance from first to third, I don't mean running distance around the base path. I mean if the player at third base had to make the throw over to first base. What's that distance? That's what I'm looking for. Okay, well, we could use the Pythagorean Theorem to do this. That's 60, that's 60. Or we could make use of our special triangles. Okay, these angles are 90 degrees. That means when you draw this line straight across, you're cutting that angle in half. Cut a 90-degree angle in half, you get a 45. Okay, 45, 45, 90 triangle, that's one of our special triangles. If you know this side length, you automatically know the hypotenuse. Hit the side lengths with a radical 2. Okay, so 60 radical 2, whatever that is. If you want a decimal approximation, use a calculator, but be comfortable just leaving it like that. Okay, that's the length that the third baseman would have to throw in order to get somebody out on first. So if the hit goes down the third base line, third baseman fields it, got to make a throw of 60 radical 2 feet to get the batter out. Okay, so a couple things. Distance in the xy plane, application of the Pythagorean Theorem. And also remember, the Pythagorean Theorem can be used to find some of these lengths indirectly. Remember the first thing we talked about, the very first video. Why do you want to study trigonometry? 1, indirect measurement. Well, we haven't even gotten to trigonometry yet, and we can already do some indirect measurement. We're going to expand on that quite a bit throughout the course. Okay, so, and also don't forget your special triangles, 30, 60, 90 triangle, 45, 45, 90 triangle. Remember, commit those to memory. They're going to come up over and over again. So we've got one more preliminary video before we actually get to the trig functions.